Good evening, friends. Welcome to today's YouTube live session. And in this session, we will start with very interesting part from the calculus, which is called derivative, or it is also called differentiation. So don't get confused with these two different names. So it's a derivative, or it is also called differentiation, right? It's just a name of the process. So we have to study here the derivative and differentiation. We already have a certain background of this derivative or differentiation in previous years, right? So first of all, we will see the introduction of the derivative, right? So what exactly the meaning of the derivative, what is the concept behind the derivative, that we will learn first, and after that we will revise all the basic things that we already studied in previous year. We will sort out all the important formulas, and then after that we will touch to the first section of this chapter, which is called composite functions. So let me, if everything is okay, so let me start with today's live session on this derivative or differentiation. So let me start with what exactly it is derivative, what is the concept behind the derivative. And so many of the time students complains me, where exactly is the mathematics around us, or what is the use of the mathematics. We cannot see the mathematics around us, there is no use of mathematics around us. So this kind of questions I usually hear from the students. But let me tell you, friends, derivative is already there around you. It is there in your house, it is there around you. So let me give you a few examples on that also. So mathematics is always around you. Okay, so before that, let me introduce what exactly the derivative is first. See, this calculus part is all about the function. Calculus is all about the function. Calculus is all about a function and its graph and its details. So let me talk about one function. So let's consider y equal to f of x is a function. So let's say you know exactly the meaning of function. Let's say y equal to f of x is a function. If you substitute the value of x, you get different values for y. So here I am drawing one graph for the function. So let's try to draw one graph for this function. So I am drawing one random graph for this function. Let's say this is the graph of that function. And to understand what exactly the derivative, let's take few values on that graph. So let's say this first point on the graph indicates the x coordinate. So I am trying to plot the x coordinates on x-axis, and let's plot y coordinate on y-axis. So this is the graph which represents this function y equal to f of x. You already know how to draw the graphs and everything. Okay, for this x, obviously there is a corresponding value of y on the same graph. So if it is a x, then there is a corresponding value of the function at this point. Let's mark this as f of x. So for this x, the corresponding value of the function is, let's say, f of x. But now I am taking another value of x. Let's say this value of x lies somewhere with plus h distance. I am adding certain h distance or h value in this particular x. So obviously the next coordinate becomes x plus h. So try to understand what exactly this h is. So we call this h as the interval difference. So what is h? H is nothing but this interval difference between these two values of x. So which is a next value of x becomes this x. X means this distance plus this h. So obviously the next value is x plus h. Maths is a symbolic language. So we can say for this value of x, there is a corresponding value of the function, and let me mark it as f of x plus h. So here we got these two values of x and two values of y. Y means function, right? Okay, so let me mark with certain notations. So this value of x, I am marking it as x1. This x plus h, so let's mark this as x2. Then this f of x, I am marking it as y1. And this f of x plus h, let's mark it as y2. So what exactly is the derivative? If you remember, we already studied a formula for the derivative in your previous year, right? So it is called first principle. So what is the first principle? So what is the first principle? So first principle is actually a special limit. That special limit is called derivative. That special limit is called derivative. And the symbol for the derivative is f dash of x. Symbol for the function is f of x. Maths is a symbolic language. So we say f of x is a function. But if you want to represent a derivative, represent it as f dash of x. So this is the symbol for the function. This is the symbol for the function. And this is the symbol for the derivative. Right? So I am representing it as a f dash of x, and you know that derivative is a special limit. Derivative is a special limit, and that special limit we write in this way: limit x tends to 0, f of x plus h minus f of x divided by h. So this formula is called first principle, or this special limit is called derivative. The special limit is called derivative. Now, let me explain you the exact concept behind this derivative, or exact concept behind this special limit. Let's try to understand this thing from this particular graph. So we already covered these two values of x and two values of y over here. If you are working on this very carefully, so try to understand this f of x plus h is nothing but y2 minus this f of x is nothing but y1 divided by, what is this h? H is actually the difference of these two x values. If you check this x2 minus x1, try to subtract x2 from x1. So x2 is x plus h and x1 is x. So here I am taking the subtraction of x2 from x1. So what is left? Plus x and minus x cancels. So what is left is h. So here, if you observe, this h is present in the denominator, which is nothing but the subtraction of x2 minus x1. So right. So technically, in general, what is a derivative? Derivative is some difference of y divided by difference of x. If you observe this, it's a y2 minus y1, which is the difference of y value. This is a x2 minus x1, which is a difference into x values. So, what is the derivative? So, derivative is all about this ratio. So, try to understand this very important ratio. So, in general, we say derivative is all about difference in y divided by difference in x. So, it is actually a difference in y. So, what is the derivative? Derivative is actually a ratio. Ratio of difference in y divided by difference in x. So it's a difference in y divided by difference in x. Not exact, this is the definition of derivative, but somewhat derivative we can correlate with this ratio, and this ratio is change in y upon change in x, or we can write down this thing also in this way. This is like a difference in y, or we can say change in y divided by change in x. So this ratio is called derivative, right? So not exactly, but we can correlate that derivative in that particular sense. So let me explain you what this, there is a one more notation for the derivative. If you recall, this is actually y2 minus y1 divided by x2 minus x1. There is a one more notation for the derivative which was there in a previous year. This y2 minus y1, they represent it by delta y. So try to understand, it's actually y2 minus y1 divided by x2 minus x1. So they represent this y2 minus y1 by delta y. They represent this x2 minus x1 by delta x. Now this h, they represent it as delta x tends to 0, and you know that maths is a symbolic language, so they represent this f dash of x by dy by dx. You know that this dy by dx is symbolically represent the derivative, right? So this dy by dx represents a derivative. So why two different symbols for the one single concept? This is the concept of the derivative, but why we are facing these two different symbols? The reason is quite interesting, because two famous persons, one is a physicist, second one was the mathematician who worked on this concept of the calculus, more specifically on the derivative. One was a very famous personality, Newton. So Newton worked heavily on the calculus. Really worked heavily on the calculus, and he worked on the derivative, and here Newton gave us this particular symbolic presentation of the derivative. So he used this kind of symbols like f dash of x, f of x plus h, f of x and h. Now, what about this? This is also a symbolic representation of the derivative, but two different peoples were working on the same concept. So the second person who worked on the same concept was the Leibniz. And we say this notation of the derivative is given by the Leibniz. So actually it's a one concept but two different notations. So this one was given by the Newton and this one was given by the Leibniz, but technically they have a same meaning. So this is y2 minus y1, they represented it by delta y. This is x2 minus x1, they represented by delta x. For the h, it's a delta x tends to 0, and for the f dash of x, symbolically we say it's a dy by dx. So this is the Newton's notation for the derivative, while this is Leibniz notation for the derivative. Okay, so let me explain you what exactly is the derivative conceptually. Now this is theoretically we understood what exactly is the derivative, or graphically we got somewhat sense about the derivative. So, but this is very theoretical. This is very theoretical what exactly derivative means. So till this particular point, what we got is, what is a derivative? Derivative is a certain ratio. What is a derivative? Derivative is a certain ratio. A ratio of what? Change in y divided by change in x. So it's a change in y divided by change in x, or difference in y divided by difference in x. So this particular ratio somewhat correlates with the derivative. What is its exact meaning, or why this ratio is important in mathematics? Or even I can prove that this ratio you always find around you. It is there in your house. It is there around you people, and daily basis you find this particular ratios. On daily basis you can observe this kind of ratios around you. Okay, let me explain you now the concept of the derivative with few examples. Right? Now, derivative is the difference in y divided by difference in x. What it represents is change in y with respect to change in x, or we can say change in one variable with respect to another variable. So friends, what is a variable? What is variable? Variable is a term whose value goes on changing. So value goes on changing. So it's not a constant. What is a constant? There are two types of terms. What is a constant? So constant is a term whose value remains same throughout, whether it's in India or in US or in Europe or anywhere else on this earth. So this 5 means 5. So which is a constant whose value never changes, right? But what is a variable? Variable means whose value changes with respect to time or with respect to some other case, but it goes on changing, right? So the variable, it is a term whose value always changes, but a constant whose value remains same throughout. Now I am talking about this concept of variable. What is a derivative? Derivative is a ratio of change in one variable with respect to change in another variable. It's a change in one variable with respect to change in another variable. So where exactly we see this particular situation? So now, see, try to observe. I am giving you a very simple household example. So during our any kind of parties like a birthday or any celebration, we try to inflate the balloon, right? For the celebration, we put so many balloons for the party. So, like for the birthday. So, we inflate a balloon. Initially, if you observe, balloon is a flat thing. But what if we try to put some air in it? So, we try to blow it with a certain air. So, now because of that air, the what is happening with the balloon then? If you inflate it with the air, its volume goes on increasing. So it's a continuous process, friends. So I'm talking about derivative, and derivative is applicable for the continuous process. So what is a continuous process? Here initially the balloon was flat. The balloon was flat, and then we are inflating it with air. So now what is happening with the because of this inflation? So its radius is increasing, its volume is increasing. So assuming that balloon as a sphere, imagine its radius is increasing, its volume is also increasing. So as far as this ratio is concerned, we can say change in volume with respect to change in radius. Change in volume with respect to change in radius. Try to understand, this is a very important concept. This is a very important thing. What exactly is the derivative? And definitely it will help you in your graduation. This concept of derivative is very, very important, and definitely it will help you in your graduation. Or you can find out this thing around us. See, so I'm explaining you the concept of derivative with one simple ordinary example that we already know from the childhood. So inflating a balloon with a air. So what is happening here? The radius of the balloon is increasing, its volume is also increasing. So the change in one variable with respect to another variable, this ratio is called derivative. Change in one variable because of another variable is called derivative. So what is exactly happening with the balloon? So its volume is increasing as its radius is increasing. How to write it in the form of the derivative, which is quite simple. This is the way that you have to write dv by dr. This is the symbolic presentation of that inflating balloon. What is this dv by dr? It's a change in volume with respect to change in radius. So it's actually a ratio of change in volume with respect to change in radius, right? So we have to write it as dv by dr, which is also called rate of change of volume with respect to radius, or we can say derivative of v with respect to s, or derivative of v with respect to r. Try to understand, this is very important thing. How to read this? It's a dv by dr. So we read it as derivative of v with respect to r. This is the bookish language, but let me tell you what exactly its meaning is. It's a change in volume with respect to change in radius. It is actually change in volume because the volume of the balloon is changing with respect to its radius. Let me explain you this concept of the derivative using one more example. The balloon, it's an ordinary example. So we already know. So let me give you one more ordinary example to understand the concept of derivative. It is there in your home. It is there around you. So every early morning, we all Indians like tea, right? We all Indians like tea. For that tea, to prepare a tea, so we boil water, right? So boiling water is an best example of the derivative. So let me explain you how a derivative plays a role in a boiling water. So it's very interesting concept. Preparing a tea requires a boiling water. So what happens with the boiling water if let's say I'm considering here boiling water whose temperature is 100 degree. So boiling water means it's 100 degree. What will happen if we suddenly switch off the gas and we keep that particular boiling water under a normal room temperature without heating? What will happen with that water? Obviously, once we switch off that heating process, obviously the temperature of the water goes on decreasing. So that 100 becomes gradually 90 degree, then 90 becomes 80, 80 becomes 70, then so on. And after a certain time, it will take a room temperature, right? After a certain time, it will reach to the room temperature. Let's say the room temperature is 25 degree, right? Okay, what is happening with the boiling temperature of the water? What is happening with the temperature of the water? Initially, it was a boiling water. Boiling water means initially it was with a 100-degree temperature. Now suddenly you are switching off the heating process. Then after, what is exactly happening with that water? Its temperature goes on decreasing, but which is the second variable which is playing here? The second variable which is playing here the role is the time. So initially the time was 0. So exactly the boiling water temperature where we measured its temperature, let's say it's 0. Then after 5 minutes, let's say it's a 90. After 10 minutes, let's say it's a 80. After, let's say 15 or 20 minutes, it's a 70. Or let's say after 1 hour or after 60 minutes, it reaches to the normal room temperature of 25 degree. So friends, let's try to understand what exactly happening in this particular experiment. So here the temperature of the water is changing and the time is also changing. How to write it? This is the derivative. So the derivative is actually a ratio. Ratio of what? Derivative is actually a ratio. Ratio of what? Ratio of the change in one variable with respect to another variable. So derivative is actually a change in one variable with respect to another variable. So here it's a change in temperature. It's a change in temperature of water with respect to change in time. Am I correct? So we can say t is a time. So change in time. Let's represent time by t. So here also it's a ratio. Ratio of what? The temperature is changing as time is changing. Changing means variables. So here the theta or the temperature of the water is a variable. Time is also a variable. The temperature of the water is changing as time is changing. So we can say change in theta with respect to change in temperature time. How to write it in the form of the derivative? This is the symbolic presentation, d theta by dt. So this is d theta by dt. How to read it? It's a difference in temperature or theta with respect to time, or it is a derivative of theta with respect to time, or we can say it's a derivative of theta with respect to time. So this is the way that you have to read this symbol. It's a derivative of theta with respect to time, right? Or it's a change in temperature with respect. You people got this concept of the derivative with such simple examples. So I give you 2 minutes to think over where exactly you will find this particular ratio change in one variable because of second variable. So just try to at least pick one example around you which gives you this kind of a ratio, change in one variable with respect to another variable. And let me tell you friends, so derivative is always there in physics. Even you will find the derivative in chemistry, and even you will find this derivative in biology also, right? So where exactly this, let me explain you this example of the derivative and its role in biology, right? Or once again, let me give you one simple example of this particular ratio with one household example. So many times we eat curd. So how a curd forms, right? So a process of conversion of milk into a curd, right? आपण त्याला म्हणतो दुधाचं दही बनवणे, right? So हे जे दुधाचं दही बनवणे हे सुद्धा डेरिव्हेटिव्ह आहे, right? So you will get surprised by knowing that so conversion of milk into a curd is a best example of the derivative. So how this particular process occurs? So let me explain you friends. So initially when there is a milk, we pour some bacteria in it. So right, so there are good bacteria that we try to pour into a milk. Good bacteria, त्याला आपण मराठीमध्ये आपण म्हणतो आपली आई विरजण टाकते. Yes, so आपली आई विरजण टाकते, right, दुधामध्ये. काय होतं त्यानंतर त्या प्रोसेस मध्ये काय होतं? Yes, so once we pour some bacteria into a milk, that bacteria, that good bacteria multiplies itself. That number of bacteria multiplies itself, And since that number of bacteria initially, let's say it's 100, then that becomes 200, 200 becomes 400, 400 becomes 1600. They grow themselves to the exponential level, and at the end of the process, that milk get converted into a curd. So right. So here comes the concept of the derivative. What exactly is happening here? So here, if you observe, there is a one more interesting thing which is happening, right? So the process is actually the number of bacteria are increasing. So here the ratio comes is change in number of bacteria. Change in number of bacteria with respect to change in time, right? So let's say the number of bacteria I am denoting by the symbol N, and let's consider T for the time. So what is happening here? So in this process of conversion of milk to the curd, whenever we initially introduce few bacteria in it, so after that number of bacteria multiplies itself, that goes on increasing with respect to time. Let's say initially there are 100 bacteria. So right, so time is 0. Then that bacteria multiplies to 200 in 5 minutes, let's say. After 10 minutes it becomes 400. So in this particular process, what exactly is happening? This number of bacteria are increasing as the time is also increasing. So the number of bacteria is increasing, time is also increasing, right? But the two variables are playing the role. So change in number of bacteria with respect to change in time is the concept. And this particular ratio correlates with the derivative. And how to write it? This is the symbol for the derivative. So this time is the main factor which plays the important role here. So we can say this is the derivative with respect to t, or read it as derivative of bacteria as n. So we write it as dn by dt, which is called rate of change of number of bacteria with respect to time, or we can say it's a derivative of n with respect to time. So if you observe, derivative is there in biology. With this simple example of process of conversion of milk into a curd, you can understand derivative is there in your house, right? Derivative is there around you. So right, so what are the examples you got till particular up to this point of this lecture? Inflating balloon is an example of the derivative. So temperature of the water which is changing is the example of the derivative. Conversion of milk into curd is an example of the derivative. Let me give you one simple example from the chemistry. So right, so derivative also plays an important role in chemistry. So in chemistry, so whenever we carried out a reaction, obviously reactants plays a role, right? So what happens with the reactant? As the time, it's a time versus concentration of the reactant, let's say. So initially there is a very high concentration of the reactant. As the time changes, this concentration of the reactant goes on decreasing, right? So what is happening here? Initially the concentration of the reactant is very high initially when we start a reaction. After a certain time, its concentration goes on decreasing. Why? Because the product is forming out from that reaction. So the concentration of reactant goes on decreasing as the time is increasing. How to write it? So it's a derivative with respect to t. So read it as derivative with respect to t. And what is the numerator here? This change in concentration of the reactant. So let's say Ca. So this is rate of change of concentration with respect to time, or change in concentration of reactant with respect to time. See, observe this ratio. Derivative is all about this ratio, which is a change in one variable with respect to another variable. It's a change in one variable with respect to another variable. So here there is a concentration of reactor which is changing, reactant which is changing with respect to time. As the concentration of the reactant goes on decreasing, time is also increasing. So this ratio is called derivative. And how to read it? It is a derivative of concentration of reactant with respect to time. So here derivative also plays a very important role in chemistry. So what is your observation, friends? The maths. Maths is such an important language which plays role everywhere. So maths is there in physics, maths is there in a chemistry, maths is also there in a biology, and more or less maths is also there around you. It is always there around. I can give you hundreds of examples around you which correlates with the derivative. So right, so already I explained you 2-3 examples, household examples. I can say household examples of the derivative. So I hope you got this concept of the derivative. This is what actually there in your textbook. So try to understand. Textbook never tells you the real story about the concept. And why we hate the mathematics? It's all because of we don't know where exactly it is applicable. We don't know the exact application of the mathematics. That's why we hate calculus, or that's why we hate these concepts of the calculus, because we never like this kind of formulas. Right? We never like this kind of formulas. But mathematics is all about that hidden sense. So there is a certain hidden sense behind these formulas, and it is our role to analyze that particular sense behind that particular concept, and this is called derivative by first principle. Right? This is the formula for derivative by first principle given by the Newton. This is the formula for the derivative given by the Leibniz. Right? And these two formulas in general never speaks about the sense behind that formula. And what is the sense here? The sense is quite simple, which I already explained you. Derivative is all about a ratio, and it's a ratio of one variable with respect to another variable, or we can read it as change in one variable with respect to another variable. So finally, I hope with this explanation you got the concept of the derivative, and above all you got the sense behind the derivative, and above all you got why this derivative is important for your graduation. So right, so I hope this entire 45 minutes discussion on single concept of the derivative will help you in graduation in understanding what exactly is the derivative and how it is applicable in different processes. Right? Okay, so finally let me write down our own symbol dy by dx. This is the main symbol of the derivative. So we can say how to write a symbol of the derivative. Every process has its symbol. So read it as derivative with respect to x. How to read it? Derivative with respect to x. This is the way that you have to read. So it's a derivative with respect to x. Now here, if you observe, we are trying to find the derivative of this y with respect to x. So read it as derivative of y with respect to x. Right? So this is the way that you have to read this dy by dx. It is a derivative of y with respect to x. What if I consider this dv by dr? How to read it? How to read it? It is a derivative of v. It is a derivative of v with respect to. It is a derivative of v with respect to radius. So where you found this? In example of inflating a balloon with the air, change in volume with respect to change in radius. How to read this? d theta by dt. Assuming theta as a temperature. Assuming theta as temperature. So we can say it's a derivative of theta with respect to time t. So right. So this is the way that you have to read a symbol of the derivative. And let me tell you, friends, so we have a definition of the derivative. I already explained you this particular definition of the derivative, which is called first principle, or this concept of the derivative as Leibniz notation. So right. So I hope you got this introduction of this derivative, what exactly the meaning of the derivative, and using this concept. If you remember, in previous year we derived so many standard formulas using first principle. If you remember, we derived so many standard results using or by taking help of the first principle. So let me list out all the standard formulas that we derived using first principle. It will be better if you write down all these important formulas along with me. So calculus is a very interesting. It is one of my favorite section of the mathematics. I personally like the calculus, right? From my initial years of the school level or the graduation level, I personally like calculus. I will love to teach you the calculus, right? I can talk number of hours about the calculus. So I hope you will enjoy calculus along with me. So let me write down, friends, all standard formulae. So we are talking about the derivative, so standard formulae in derivative. So let's list out some from the algebra. So first one was, read this as derivative with respect to x. So you know that derivative of constant is 0. Derivative of constant is 0. Second formula was derivative of this x with respect to x is 1. Always remember, if the variable is x and we are differentiating it also with respect to x, then outcome is always 1. So this is just a symbolic in the form of x. But if it is derivative of y with respect to y is also 1. If it is a derivative of t with respect to t is also 1. If it is a derivative of theta with respect to theta is also 1. So this is the way that you have to analyze this formula. It's a derivative of x with respect to x is 1. You know that a derivative of individual constant is always 0. Like this is the example, if it is a derivative of constant 5, you know that its derivative is 0. If it is a derivative of 7, answer is 0. So always the derivative of a constant term is 0. Derivative of x with respect to x is also 1. The next one, if you remember, the derivative of root x was 1 upon 2 root x. So then fourth formula was derivative of 1 upon x, and it was minus 1 upon x square. And let me tell you again, we derived all the standard formulas of the derivative using first principle in previous year. So we derived all the standard formulas of the derivative by first principle, but there is no need to recall all that process. Just try to remember these standard results. Then one important formula from this algebra which is required to solve the problem, it's about a derivative of x raised to n. So what was the derivative of x raised to n? If you remember, it is n into x raised to n minus 1. So derivative of x raised to n is n into x raised to n minus 1. Let me explain you this thing with one example. What is the derivative of x raised to, let's say, 7? So here the n value is 7. Please apply. Answer is 7 into x raised to 7 minus 1, which is 6. So answer is n into x raised to n minus 1. It's a 7 into x raised to 7 minus 1. One more for you. It's a derivative of, let's say, x raised to minus 3. Don't worry whether it's a positive or the negative power. You immediately apply it. Apply this formula as x raised to n. So derivative of x raised to n is n into x raised to n minus 1. So this is x raised to n. It's a simple n into x raised to minus 3 minus 1. Understand this? It's a n into x raised to n minus 1 minus 3 minus 1. You can express it as minus 4. So power may be anything. It may be positive, it may be negative, or it may be a fractional number. So right. So I think from the algebra we derived these many number of formulas. Then let's say from the trigo. So trigonometric section, obviously 6 trigonometric ratios, 6 trigonometric derivatives. So first one is derivative of sin x. So what was the derivative of sin x? Derivative of sin x is cos x. Then derivative of cos x, if you remember, derivative of cos x was minus sin x. Then third one in the list is derivative of tan x, which is sec square x. Fourth one, derivative of cot x, if you remember, formula was minus cosec square x. Then the next one is derivative of sec x. Derivative of sec x is sec x into tan x. And the sixth one was derivative of cosec x. And the formula for the derivative of cosec x, if you remember, it was minus cosec x into cot x. So 6 trigonometric ratios means 6 formulas, right? And one, let me repeat once again, we derived all these important derivatives or standard derivatives using first principle in our previous year's chapter, right? Okay, so let me explain you once again the 6 important formulas, and there is one simple trick or the hint in the 6 formulas. So try to understand. Derivative of sine x is cos x, derivative of cos x is minus sine x, derivative of tan x is sec square x, derivative of cot x is minus cosec square x, derivative of sec x is sec x into tan x, and derivative of cosec x is minus cosec x cot x. Okay, there is a one simple trick to remember this formula. So if you observe, there is a one interesting connection. If you observe, this is the trigonometric ratio with c, right? Cos x, there is a c, right? The letter is c. If you observe this cot x, the letter is c. If you observe this cosec x, the letter is c. What I am talking about? I am talking about the formula number 2, which is the derivative of cos x, and it is a negative. If you observe the formula number 4, it is derivative of cot x, which is minus cosec square x. So minus is involved here in the formula number 4. And if you observe the derivative of cosec x, it is a minus cosec x cot x. So if you observe here also, it starts with c and answer is negative. So cos starts with c, answer is negative. Cot starts with c, answer is negative. And it's a cosec which starts with c and answer is negative. The funny part is all the trigonometric ratio which starts with c, if you observe, its derivatives are negative. So it's a cos starts with c, its result is negative. Then it is a cot whose result is negative. Then it's a cosec, result is negative. How to remember it then? The trigonometric ratio which starts with c always gives you the negative derivative. Okay, then we derived few results from the exponential and logarithmic cases. So I'm talking about the next one, exponential and logarithmic. So from that, the first one and the very important one, the derivative of e raised to x is e raised to x. So it is the only function whose derivative remains same. So the derivative of e raised to x is always e raised to x. Then let me give you the second important formula, derivative of a raised to x. If you remember, the formula was a raised to x into log a. Let me explain you this thing with one example. If it is a derivative of 7 raised to x, you have to write it as 7 raised to x into log 7. So right, so it's a means constant. It may be a 5, 3, 2 or 1. So derivative of a raised to x is a raised to x into log a. For example, derivative of 7 raised to x is 7 raised to x into log 7. Let's say it's a derivative of 5 raised to x. Answer is 5 raised to x into log 5. So this a is always a constant. And the last one in the list is derivative of log x. Very important formula. So derivative of log x is 1 by x. So derivative of log x is 1 by x. Let me tell you friends, we derive all these standard derivatives. All these standard derivatives in previous year using first principle. And the standard derivatives are required in this particular year to solve the problems of the derivative. So it's your job to remember or list out all these very important standard derivatives, right? I hope you will remember this all situations. It's always better to apply them number of times to recall. So right, it's not about remembering the formulas. It's not about listing out them for the 100 of times. It's better to apply them to the number of problems. Then and then only you can remember all the standard formulas. Then in last 5 minutes, let me explain you one more basic concept from the derivative. If you remember, I'm talking about the rules of differentiation or algebra of the derivative. So I'm talking about the next heading, rules of differentiation. So please write down the next heading, rules of differentiation. Please write down this next heading. It is all about rules of differentiation. So rules means I am talking about its algebra. Algebra means addition, subtraction, multiplication, division, or the role of constant. Right? So let me list out the first formula. The first one, what if it is a function is with k. It's like let's say y is equal to k times a function. Y is equal to k times a function where k is a constant. So always remember, if you want to differentiate this y with respect to x, if a constant is present in multiplication, always keep that constant outside the derivative and just differentiate whatever the function left. So what I am talking about here is, let me explain it with this simple example. What if it is 5 times log of x? If you want to differentiate this derivative of 5 times log of x, so always remember this 5 is in multiplication with this log x. So it's always better to keep that 5 outside the derivative and simply differentiate that particular term. So always remember, if a constant is present in multiplication or in division, then and then only you can keep that particular constant outside the derivative process. So this phi is a constant, you can keep that constant outside the derivative process, and what is left is a simple standard derivative, and you know that derivative of log x is 1 by x. So this is the first rule. The second rule is, let's say y is equal to, it's an addition of the two different functions like f of x plus g of x, or in previous year we represented it as a u plus v, right? So which is called addition rule. If you want to differentiate this one, see, this is the way that you have to write actually. So it's a symbol for the derivative. This is the symbol for the derivative, and please read it as derivative with respect to x. Or we can say it's a differentiation with respect to x. So this is the derivative with respect to x. So this is derivative with respect to x for this y is always the derivative of u plus derivative of v. So it's a simple meaning is there. If two terms or the two different functions are present in addition, then you have to take a separate derivative, right? So let me give you one example on this. If it is y equal to e raised to x plus sin x, if you observe these two different functions are present in addition, do one thing, so differentiate them individually, or you have to take separate derivative. So it's a in simple language, if two or more than two functions, it's not about the two function friends, there might be two or more than two functions. So if two or more than two functions are present in addition, then you have to take the separate derivative or individual derivatives. So here I am differentiating this e raised to x and sin x individually, or I am taking the separate derivative. So derivative of e raised to x is e raised to x, and the derivative of this sin x, you already know that formula is cos x. So here we got the answer. So the rule which is applicable for the addition, the same rule is also applicable for the subtraction. In subtraction also, you have to differentiate separately to the each and individual functions. So let's say in the same example, instead of plus there is a minus sign. There is no change in process at all. Just differentiate it individually. Take a derivative of e raised to x separate, and then the derivative of sin x separate. Once again the story remains same. Derivative of e raised to x is e raised to x, while derivative of sin x is cos x. So whether it's addition of the function or subtraction of the function, the rule remains same. You have to differentiate every function separately. But there is a product rule which is something different. So if you observe this case number 3, which is called product rule. So let me explain you friends about this product rule. So product rule means they are talking about y is equal to u into v. So two different functions present in product. So how to differentiate this u into v? So obviously this is not like a addition or the subtraction as individual derivatives. There is a slightly different rule that you have to apply in multiplication. So formula is, I am assuming this as a first, this as a second. So differentiate u into derivative of v plus v into derivative of u. This is the formula that you have to remember. So always remember that formula in this way. It's a u into derivative of v. So please remember in this way. It's a u into derivative of v. Then switch over the positions. It's a v into derivative of u. So you have to remember this thing in this way. It's a u into derivative of v plus v into derivative of u. Let me explain you this thing also with one simple example. Let's say y is equal to, it's a log x into tan x. So right, so this is like a u and this one is like a v. So let's differentiate this with respect to x. So it's a u into derivative of v plus v into derivative of u. This is the way that you have to write a product rule. So this is u, this one is v, and this is the way that you have to write u into derivative of v, then switch over the positions, v into derivative of u, and you already know the formula is derivative of tan x is sec square x, and you know that derivative of log x is 1 by x. So this is the way that you have to remember. Derivative of tan x is sec square x, derivative of log x is 1 by x, and this is called product rule for the two functions. So if it is a y is equal to u into v, it's a u into derivative of v plus v into derivative of u is the formula. But under this u into v, let me give you one rarely used formula for the three terms u, v, w. How to tackle these u, v, w or the three terms in multiplication? So there is a one simple way of writing this particular formula. Just try to observe it. So dy by dx. Just write down all the three derivatives. So here I am writing the derivative of u, keep some space, then derivative of e, then keep some space, and then derivative of w. Then the real trick is, if you are trying to find the derivative of u, then write down rest of the two functions v and w as a coefficient. Then since you are taking the derivative of v, then write down u and w as its coefficient. Then if it is a derivative of w, then write down u and v as their coefficient. So there is a simple trick to write a derivative of u, v, w. It is rarely required, but remember this formula also, how to tackle if three different functions are present in product. This is the way that you have to differentiate if three functions are involved. And in rules of differentiation, the last case number 4, which is called division rule. Division, or we can say quotient. So it's like y is equal to u by v. So if two functions are present in division, y is equal to u divided by v is the case. Then always remember the hint. The hint is start with v. So this is the hint that you have to remember while differentiating a u by v case. Always remember start with v, which is present in the denominator. So this is the way that you have to differentiate it. Start with v. See this hint? You have to start with v. If it is a v, then it's a derivative of u. Right? Then switch all the things in this way. Then minus sign, then u into derivative of v divided by, in the denominator you have to write v square. So this is a formula for the u by v rule, or if two different functions are present in division, u by v. What you have to remember here is simple, start with v. If you start with v, then take a derivative of u. Then switch over the things, u into derivative of v, and you can remember this very easily. It's a v square in the denominator. So this is the formula to find division or the quotient rule. But let me give you one simple hint. You can, if this particular formula is very difficult to remember, let me give you a simple trick. The trick is, if it is y equal to u by v, every u by v situation we can convert it into u into v. So in this particular way, you can convert this into u into v. There is no need to remember this particular formula. So because every rule which is a u by v, you can convert that u by v situation into u into v. So only thing is, this u remains u, but this 1 by v acts as a v in a product rule. So see what I am trying to tell you. If you don't want to remember this particular formula, then you can convert that u by v case as a product rule. So this is u and this acts as a v. So u into v, then you can freely use this formula to find out the derivative of this rule. So this is called the rules of differentiation. So this particular, all these formulas are called rules or the algebra of the derivative, we can say. So the first formula is, if it is y equal to k times f of x, If a constant is present in multiplication, then do always one thing, keep that constant outside the process of the derivative. This is the simple meaning of this formula. Okay, then the second one, if the two different functions are in addition or the subtraction, the process is simple. You have to differentiate every term separately. Then there is a product rule, u into v. The process is quite simple. It's a u into derivative of v plus v into derivative of u. You have to remember u into v in this way. It's a u into derivative of v plus v into derivative of u. Then this special formula, if it is u, v, w case, three functions, but it's rarely used. This is the important one. But let me give you this particular formula. So it's very easy to remember. There is a simple trick behind it. And then this is called quotient or the division rule, like u by v. The hint is start with v, v into derivative of u minus u into derivative of v divided by v square. And if you hate this formula, if you don't want to remember this formula, do a simple trick. The trick is, if it is a u by v, then separate this u into this 1 by v as a separate function. Then you can apply a product of this assuming the u and this term as a v, and then you can apply u into v rule. Okay friends, I hope you enjoyed this YouTube live session on introduction of the derivative. See, in this introduction, most of the part we already studied in the previous year, but those who already forgot about this derivative, I hope this session helped you in recalling, first of all, first principle, and above all, exactly what is the derivative, what is the concept behind the derivative, what is the meaning of derivative, and how a derivative plays a role around us. There is a derivative in our everyday life, there is a derivative in kitchen, there is a derivative around you. So always try to analyze derivative as a ratio of one variable with respect to another variable, or we can say derivative is change in one variable with respect to another variable. This ratio of change in one variable with respect to another variable correlates with the derivative. Try to find out such a simple examples around you that gives you the importance of the derivative. Then I already explained you how the derivative plays a role in physics, then in chemistry, in bio, or in some few household examples also. And after understanding the concept of derivative, we revised all the standard derivatives that we derived using the first principle. So just we listed out all the standard derivatives, and at the end we talked about the rules of differentiation, like constant rule in product or addition, subtraction, multiplication or division. So friends, thanks for joining this YouTube live session. I hope you enjoyed this introduction of the derivative. In next lecture, we will actually start the first section of this chapter, which is called composite function. And it's my request, don't miss that particular section. The reason is composite function is the heart of the derivative. We cannot neglect it, because once we know the derivatives composite, once we know how to take a derivative of composite, then rest of the chapter is very simple for you people then. So please don't miss the next lecture of how to find derivative of composite function, which is the heart of the derivative. So once again, thank you friends. Thanks for joining today's YouTube live session. Till tomorrow, take care. Goodbye. I'm signing off.